But you've done you've graphed systems before, many lines in one grid. Now it's just inequalities, right? So you exactly, that's what it's gonna look like, yeah. And I will tell you right up front. So I'll show you why we're gonna do reverse shading not with systems. Okay, you heard of Desmos, I'm sure. Yeah, you love Desmos, yeah. Okay, just pay attention 1 second here. 2x minus, I'm just making this up for now, greater than 30, let's say, right? Oh, it doesn't like caps. Okay, we're gonna fix that. So you have one inequality there, right? It's graphed for you. So let's say you come along and you have another one, and this one is gonna be less than 50, let's say. So right now, I've used regular shading, correct? Which one would be the solution to the system right now? So this is now true, right, for the red line. That is all true for the blue line. Where is the solution to both of them? Where would you say this sliver here, right? Yeah. Does that make sense? Yeah. However, let's add a third one to the mix. Would you be able to tell which one is the darkest region if you shade? It would be very hard to tell because you're gonna have like, wait a minute, two overlap over here, you have a third one here, like which one is now the solution region? That's why we're gonna do reverse shading so that the area that ends up not being shaded is gonna be our solution region. All right, just because I've tried regular shading before, and it always caused issues. Students weren't sure which one is it now, right? Reverse shading, if you shade everything that's false, right, you're eliminating false, 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 false. So what is left is going to be the true region for all of them. Okay, so when it's a system, I automatically go reverse shading. Okay, so if you're wondering, it's like, what should I do here? Oh, it's a system reverse shading. Okay, I will try my best to always tell you, but if I don't, we're doing reverse shading, and that's just how it is. The textbook doesn't do reverse shading, but you will end up with the same solution, okay? Don't get me wrong, we're not making it's not different, it's still the same, it's just a different approach, okay? So that's why we do that, okay? So if I added another one here, a third one, let's just do a vertical line. Right, you have one of those. There's too much going on here. Then it's hard to tell which one your solution region is. Right, in this case, it would still be this sliver here because it's shaded for all three using regular shading, right? How do you trick Desmos? If you're going to use Desmos, this is how you trick Desmos to do reverse shading. You just flip the inequality symbol. So you just do this, and then you go instead of less than, it's going to be greater than, and instead of less than, it's going to be greater than. So you flip it for all of them, and then what's left, what's not shaded, is actually the true region because I've just shaded the false for everything. Okay, so if you use Desmos to check your answer, you just have to type in the exact opposite symbol, and then it's basically going to do reverse shading for you. All right, let's go back to our notes here. I don't even know if that makes it onto the recording, probably not, but there we go. Graphing, yeah, I have a ruler, which you already do. Systems of inequalities. So the textbook jumps right into just systems of inequalities. They don't review anything. So I don't know if you noticed, we first dealt with lines, then with systems of lines. Then we took a step back. We did inequalities, just one inequality at a time. Now we're going to do systems. So I'm kind of building up a case here, okay? We proceed the same way as before, but now we will graph multiple inequalities at the same time. Same grid, right? Same plane, I should add, right? It's the same coordinate plane there. Okay. To make it easier to see the solution region, and i.e. the area that is true for all inequalities. That's what the solution region is. It's the area, right, from which every single point in that area will be true for all inequalities, okay? So to make it easier, and I'll just put this in brackets here, what I just said here, i.e. area that is true for all inequalities, we use reverse, I'll do caps, shading. Okay, we use reverse shading for systems. Okay. Note that the true region does not change. Right? It's not like we're saying, oh, the true region is now here. The true region doesn't change. It's just the shaded portion is the false region now. Okay. So so it does not change. Using reverse shading, comma, will leave the solution region unshaded. And maybe, right, reverse shading tells you that the solution region is unshaded, right? That's perhaps the key. That's the reason behind this method, right? And always keep in mind, this is eventually going to end up with word problems, okay? So we're learning skills, and then we're going to turn word problems, right? We're going to mix it up with word problems. Okay, so no corner points. Oh, AKA, let's do AKA POIs, right? Points of intersection. We've talked about that before. Right? So I'm going to give you a little bit of an illustration here. In general, you will need to label the POIs surrounding the solution region. Note that the axis does not count. Okay. You may notice that will mean something later on. So I'll just give you an illustration because sometimes it's closed in, other times it's not. So examples, and these you don't even need a ruler for, in my opinion. Just draw the lines approximately the same way I'm doing them. Basically just want a triangle somewhere in the middle of those three lines, right? And let's say in this particular example, you do your reverse shading, and it's the triangle inside that ends up being the solution region. So just shade everything around it. I want you to label this solution like that. And now this particular example shows that the solution region is actually enclosed, like it's closed up all around it, right? And so if we label A, B, and C, give every single one of these points just a name. So either on the side or right on the graph, you just label, right? You go A and give me the coordinates of that. B, you give me the coordinates of that. C, you give me the coordinates of that point, right? So you need to state them because we're going to use them later on. We're going to actually look into them. They're going to be very important to us. So you could have another example here where let's say you have a line like that and another line going like this. And let's say they cross right at that point. We're going to call that point A. We're going to shade above this line and above the other line here. This is our solution. And remember, we're using reverse shading, right? So the unshaded part ends up being our solution. In this case, you only have one corner point, and so this is your solution. I haven't done this before, but maybe I will. Let's try to draw our X and our Y axis just somewhere in there. Is our Y axis here and our X axis just right over top of it. Because oftentimes students will pick these points here as corner points. When they cross the X and the Y axis, those are not corner points. We only deal with corner points where the lines cross, okay? So A is my corner point there. And I will maybe just say arrow to it. Not POIs. This will change when we do word problems. It will change a little bit, but for now, that's just how you handle it. Okay. I guess I didn't put POIs here, right? Because then you would state it like that next to the graph. In this case, there's only one corner point. That's it. Okay. You might have 1, 2, 3, it depends on the situation. And I'd rather do examples and then just decide how to do it there. We're good? All right. I'm going on the back side here. Graph the following systems. We're going to start easy, and then we're going to do 2, and then we're going to do 3 after. Probably. So let's say I'm going to give you the way the textbook does it, just so you don't panic when you see this. So squiggly bracket, right? And then in bracket, the variables that are being used, and then some sort of inequality, and then they tell you this at the end. And then another one right under it. You will see this when I assign on the textbook. The textbook gives you the inequalities like this. You don't have to worry about it too much. Just focus on these parts right here. Right? These are your 2 inequalities at play. Okay. So they're basically just, this is the formal way of stating an inequality. So the variables x and y could be ns, p, q, whatever, but in this case it's x and y. The inequality is followed, and then it's just telling you x are all the numbers in the real number system, y belongs to the real numbers as well. So it's basically all numbers that you can possibly think of, negative, positive, decimals, you name it, right? Fractions. So don't worry about that too much, just focus on this. So let's graph that. So you take each individually like that and do what you did so far, except for we're going to end up graphing them on the same grid. So come up with your intercepts that helps you to graph it. And so we have 4x is equal to 12. Divide both sides. Watch your negatives, right? In this case, there is no negative there. So you end up with 3, 0 for your x-intercept. The y-intercept is negative 6y is equal to 12. I picked easy numbers to make it a little faster. 12 divided by negative 6 is negative 2, so it's 0, negative 2, the coordinates. Boom, right there. Okay. I will rewrite it underneath. So it's negative 6y is greater than negative 4x plus 12. And then I go ahead and divide everything by negative 6. Did you say negative, Mr. Dixon? Yes, I did. What happens when you divide by negative? Flip the sign. That's the first thing I'm going to do. Right? So I don't forget. And then I'm going to go ahead and say y. 4 over 2 is like saying 2 over 3, right? Minus 2. I just reduced that fraction. You do not need to reduce a fraction. Okay, I just can't help it sometimes, right? And so there's my rewritten, which I'm going to need to plug in. And then I will just make a note here, and I would strongly encourage you to do that too. I tell myself that this line will be dashed, and I tell myself where the true region is. Where is the true region? True is below, right? I'm going to start just doing arrows, okay? It's just faster. True is below. Where am I going to shade if I use reverse? Right? So I will say shade above. You don't need to do that part as long as you know where the true is, but I kind of like to tell myself where to shade, like just get to that part where I have to shade. So you're now done with the first inequality. Let's move on to the second one. And I will go 2x plus 3y is less than or equal to 9. I know that it's solid right there. Okay, x-intercept, y-intercept. And then it's 2x is equal to 9 divided by 2, x is equal to 4.5. Sorry, I'm going fast because I know how you know how to do this by now, right? Then it's 3y is equal to 9. I'm just here, what I'm doing is figuring out where my boundary line is going to be. So it's 0, 3. So that I will box in. I will rewrite it. 3y is less than or equal to negative 2x plus 9. Divide everything by 3. No flipping the sign, right? So that's negative 2, 3x plus 3. Very good. And then I tell myself this is a solid line. True is below as well, right? Because it's less than. Shade above. After a while, you're just going to go T down, S up, right? Like you might just shorten it as long as you know what you're doing. And now I can go ahead and graph this. And I will warn you, these numbers, the intercepts are going to start getting bigger and bigger. So you have to kind of keep that in mind for scaling purposes, right? You got to make sure you fit that in. You don't want to use a whole page for the graph, right? So let me just make sure that those are there, and let's go ahead. I think I can fit this in on a 10 by 10 grid for sure, maybe even less. But this is where I need you to, before we graph, I actually forgot this. I made a note to myself to warn you. Let's find the corner point first. Find POI before graphing. Why would I say that? Why would I say find the point of intersection before you graph on your paper? You're probably too busy copying, right? What happens if you graph it and you end up graphing your lines and they meet way outside your graph? Then we have a problem, right? Because you're not going to see it on the graph. So I would say let's go back and first type these in and see what the point of intersection is before we start graphing it on paper. So let's go ahead and grab our calculators. Y equals clear, clear, clear. Right? 2/3 x minus 2. And then it's negative 2/3 x plus 3. So I will, there's only one point of intersection really in this case. So let's graph it. My window is showing it, so I'm just going to go second trace 5. Enter, enter, enter. And it is happening at 3.75, 0.5. Which is, right, we're just fine with our grid. We don't need to go way outside our current grid, so we're good. But if this had been like negative 15, negative 10, right, then you would have had to make sure that your grid would include enough. So you would have to change your scale to make that fit. So I'm just going to go 5 each direction actually. 1, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this is my x-axis, y-axis, right? 3.75 I'm going to label that later. I'm just going to do my lines first. So 3, 0, and 0, -2. That is a dashed line. Sure, extend it, label it. Some of you are like, oh, I forgot to label on the AC. 4.5, 0, and 0, 3 is way up here. Those I don't need you to label because then it gets a little bit too busy, right? And that's a solid line. Y is less than or equal to -2/3 x plus 3. If you have the POI written next to it, you also don't need to label it on the graph. Okay, if it's written on the side somewhere, no need to, because it just gets too busy. And you'll see what I'm saying later on. Let's do the shading one at a time. I focus on my dashed line. That's the first one. I told myself that I'm going to shade above the line, correct? So let's do that. Just follow it and just go above the line. It's a little bit light. Sometimes it's probably a good idea to go light first, and then once you've figured it out, then you add a little bit of shading if you feel like you need to. Okay. But if it's not shaded, it's not an inequality. Okay. All right. Let's finish this before we end up with the bell there. So the other one, I'm telling myself also shading above, right? So I'm going to follow that line and shade above that line. Right? There you go. Which means because I used reverse shading, this is my solution region. You need to tell me that. Otherwise, right, I'm not sure if you understand. So solution region, point of intersection is stated there. There's only one, right? This is not a point of intersection. None of these intercepts are points of intersection. Okay, there's only one. If you want to make an arrow to it because these are your notes, right, that's your point of intersection. Okay. Do I need to add something here? I will just add this here, okay? Homework, page 5 and 6 in the booklet. And I will add something to it because I haven't done 3. I've only done 2, right? But you can apply your knowledge to any situation. If you just follow this, do one at a time, shade where you're supposed to shade, and whatever isn't shaded is your solution region. So I'll just give you a heads up here, because I know this one is always a problem. So this is page 5, okay? So listen carefully. This is going to be a diagonal line, right? Okay, big numbers, so watch for that. Is this going to be a diagonal line? You don't know yet. There could be things canceling out when you bring everything over. Got it? And then is this a diagonal line? It actually is because you have y and x. Right? But have you ever seen, we haven't talked too much about if it's just 3x. So how would you graph this? Because the x-intercept and the y-intercept are the same. They're 0, 0. Listen carefully here. This is a freebie. okay? When you have something like that, use points. So for example, if x equals to 2, y equals to what? -3 times 2, which is -6. So you just found a point to -6. So you can do 0, 0, connect 0, 0 with this, and then you have your line. You can pick any value for x. It doesn't matter because x is independent, okay? So plug in any x value here. You could have done 5. If x is equal to 5, y is equal to -15, right? So all you need is 2 points to graph. Does that make sense? I need you to try both of these. You might scratch your head a little bit, but as long as you have the intercepts all worked out and you have graphed your lines, then the rest I can work with, right? But because that I'm going to go by really fast. I will post the key of this, both pages, as soon as you leave, okay? And then you give that a try. All right?